Hi everyone, today me and my friends will make a presentation about software quality matrices. In our presentation, we used a simple and formal design in order not to distract your attention. Welcome to our presentation. My name is Mustafa Berkgeleş and I will talk about some basic terms, objective of quality measurement, classification of software quality metrics, and process metrics like software process quality metrics, software process timeable metrics, error removal efficiency metrics, lastly software process productivity metrics. In my presentation, I use some example to make everything clear for you. Let's start it. Before going deep, we will learn some basic terms like measurement, measure, and metric. What is measurement? Measurement. Measurement is a process of finding a number that shows the amount of something, and measure a certain size, amount, or degree of something by using instrument marked in the standard units. Metric. According to IEEE, a quantitative measure of degree to which an item process a given quality attributes. In other words, measure certain properties of software or its specification. For example, number of error found per a person. After the explanation of measurement and measure terms, you may ask this question to yourself. What do we measure? We measure process. We measure effectiveness of the process and we need to ask what does work or what does not work. We measure developer or programmer productivity, code quality, software engineer productivity. In terms of software engineering productivity, we measure design, testing, and other tasks of software engineer. Also, we measure software and management. In software, we measure maintainability, usability, and other quality factors. In management, we measure staffing, cost estimation, budget, and other activities. We measure something, but why? Why do we measure? Some of the important reasons are listed below. To improve quality of product, project, process, to determine quality of piece of software or documentation, to assess benefit derived from new software engineering methods and tools, to close gap of any problem, to help justify requests for new tools or additional training, to determine quality of work that is done by software engineer, developers, and other peoples, most significantly managers. In order for the selected quality metrics to be applicable and successful, both general and operative requirements are needed. And these two requirement types are given here. Let's start with general requirements. Relevant, valid, reliable, comprehensive, mutually exclusive. I will explain each of them one by one. Relevant, related to an attribute of substantial importance. Valid, measures the required attributes. Reliable, produce similar results when applied under similar conditions. Comprehensive, applicable to large variety of implementation and situation. Mutually exclusive, does not measure attributes measured by other metrics. Let's continue with operative requirements. Operative requirements are easy and simple, which means implementation of metrics data collection is simple and is performed with minimal resource. Does not require independent data collection and immune to biased intervention by interested parties. Actually, there are two main objectives of software quality matrices. The first one is facilitating management control as well as planning and execution of appropriate managerial interventions. The achievement of this objective is based on calculation of matrices regarding deviation of actual functional performance from planned performance and deviation of actual timeable and budget performance from planned performance. The second one is identifying situations that require or enable development or maintains process improvement in form of prevention or corrective actions introduced throughout the organization. Achievement of this objective is based on accumulation of matrices information regarding the performance of teams and units. Software quality metric can be separated into many categories. Here we use a two-level system. The first classification category distinguishes between life cycle and other phases of software system. It contains process metrics and product metrics. Process metrics is about software development process, and product metrics is about software maintenance. The second classification category refers to subject of measurements like quality, timeable, effectiveness, productivity. A sizable number of software quality metrics involve one of the two following measurements for system size. Clock. It is a classic metric that measures the size of software by thousands of code lines. As number of code lines required for programming a given task differ substantially with each programming tools. This measurement is specific to programming language or development tool used. Application of metrics that include clock is limited to software system developed using the same programming language or development tools. The second one, number of function point. It is a measurement of development resource required to develop a program based on functionality specified for software system. Software development process metrics are separated into following four categories. These are software process quality metrics. It consists of error density metrics and error severity metrics. The second one, software process timeable metrics. The third one, error removal effectiveness metrics. The last one is software process productivity metrics. We will talk about each of them. Before explanation of process metric categories, I want to ask a question to you. Is it enough to use clock? It's not. If we use only clock, how we will find the number of errors or type of errors? We cannot find. A mixture of clock, density, and severity is an ideal quality metric to programmer quality of work and performance. In previous slides, as you know, I mentioned about density and severity terms, but not a lot. In these slides, we will explain them with an example. Here, in my example, there are two different teams. Before realize, team A finds 400 errors during a software process. And before realize, team B finds 100 errors during a software process. The question is, which team is more effective in finding errors? The answer really depends on not only number of errors, but also type of errors found. The density terms refer to number of errors, and severity term refer to type of error found. One error with more severity can be more significant than hundreds of other errors. In this part, we will talk about error density matrices. When we calculate error density matrices, we need to use two measures. These are software volume measures and error content measures. Software volume measures are related to number of lines of codes and function points. Error content measures are related to number of error and others. Is also related to weighted number of errors. Weighted measures that a certain severity of the errors are considered to provide more accurate evaluation of error situation. A common method applied to arrive at these measures is classification of detected error into severity classes, followed by weighting each classes. I know these are very formal explanation because I want to make an example about it. In this example, I will demonstrate the calculation of number of code errors and weighted number of code errors. Think about a software development department. They apply two different alternative measures to the code error detected in its software development projects. These two alternative measures are number of code error and weighted number of errors in this example. As you can see in the first table, we have three classes of error severity and their relative weights. The first one, low severity, and its relative weight is 1. The second one, medium severity, and its weight is 3. The last one, high severity, and its relative weight is 9. In the second table, we will calculate the number of code error and the weighted number of code error. But how we will calculate them? The weighted error measure is computed by summing up multiply of number of error found in each severity class by the relative severity weight. As you can see, we have 42 error in low severity and the weight of low severity is 1. We will multiply 42 with 1 and the result is 42 again. Let's calculate weighted errors for medium severity. We have 17 medium severity errors. And what is the relative weight of this class? It is 3. We will multiply 17 with 3. The result is 51. There are 11 number of error in high severity class. We will multiply it with its relative weight. 11 multiplied by 9 is equal to 99. The total number of error is 70 and total weighted error is 192. There are 6 types of density metrics and each of them are given in this table. Also, we give the formulation of each of them. The code density, one of these one. The development error density, weighted code error density, weighted development error density, weighted code error per function point, weighted development error per function point are the 6 different type of error density metrics. Let's look at the formulas a little bit. When the number of code error is divided by klog, we will get the code error density value. Also, when the number of development error is divided with klog, we will get the development error density. Here you can find the abbreviations also. After the boring formal explanations, I want to make one more example to support my presentation. This example follows the example 2 and introduces the factor of weighted measures so as to demonstrate the implementation of their use. A software development department applied two alternative metrics for calculation of code error density. These two metrics are code error density and weighted code error density. The unit determined following indicators for unacceptable software quality. In the other word, if code error density is greater than 2 and weighted code error density is greater than 4, this is not acceptable. Here we have 3 classes of quality and the relative weights. The code error summary for the project mentioned in example 2. The software system size is 14 clock. The calculation of these two metrics is shown in the table. Let's examine it. Do you remember the formulation of these metrics? How we will calculate them? Let's examine. The code error density can be calculated by dividing number of code error with clock, and weighted code error density can be calculated by dividing weighted code error with clock. Let's look at the numbers. Our number of error is 70 and our clock is 40. When we divide 70 with 40, we will get 1.75. This is acceptable. As you know, if code error density is smaller than 2, it is acceptable. Otherwise, it is not acceptable. Let's look at the weighted code error density. We have 192 weighted code error and we have 14 clock again. When we divide 192 with 40, we will get 4.8. As you know, it is greater than 4. It means this is not acceptable. I think after this example, everything is more clear for you. In this part, we will talk about error severity matrices. The matrices belong to this group are used to detect adverse situation of increasing number of severe error. In situation where error and weighted errors are generally decreasing. As you can see in the table, we have two metrics. These are average severity of code error and average severity of development error. We give their formulation in this column. Let's examine it. When weighted total code error is divided by the number of code error, we can obtain the average severity code error. And when total weighted development error is divided by the number of code error, number of development error, we can obtain the average severity of development error, as you can see here. Software process time-bound metrics can be based on account of success in addition to failure events. An alternative approach calculates the average deal in completion of the milestones. As I say, there are two main metrics. These are timetable observance and average deal of milestone completion. You can find their formula in this table. The timetable observance and average deal of milestone completion metrics are based on data for all relevant milestones scheduled in the project plan. In other words, only milestones that are assigned for completion in project plan stage are considered in metrics competition. Therefore, these metrics can be applied throughout development and need not wait for the project completion. Here, we will talk about error removal effectiveness matrices. These are development error removal effectiveness and development weighted error removal effectiveness. Software developer can measure the effectiveness of error removal by software quality assurance system after a period of regular operation of the system. The metrics combined the error record of development state with failure record combined during first year of regular operations. Process productivity matrices. This group of matrices include direct matrices that deal with a project human resource productivity, as well as indirect matrices that focus on extent of software reuse. Software reuse substantially affect productivity and effectiveness. For process productivity metrics, direct or indirect, are presented in our table as you can see here. What they are? They are development productivity and function point development productivity, code reuse, and documentation reuse. As I say to you, this part is related to reuse of something, code reuse, documentation reuse, and productivity. This was the last part of my presentation. In the next part of the presentation, my friend will be with you. Also, they will mention about the process productivity too. Thanks for your listening.
Hello everyone, my name is Hassan Al Chater and I am here now. I'm responsible about product matrix in chapter 21 in our books. So I am responsible from page 420 until page 426. So first things I'm gonna speak about right now is product matrix, and goes on as you can see in this page right now: HD quality matrix measure, and HD productivity and efficiency matrix, and corrective maintenance quality and matrices. And the last point we are gonna cover it. I'm gonna cover it after my friend will cover the other topic. I'm gonna cover the software corrective maintenance, productivity, and efficiency matrices. So let's start.
Yes, guys, before I start my parts, I'm gonna show you the calculation formulas for development product, function point development product, code reuse, and documentation reuse that my friend Mustafa just explained just like a minute ago. So first things I'm gonna speak about right now is DevB, development product. How we can calculate this? DevB, if you want to calculate it, you are gonna divide DevH into KLOC. So what's DevH? DevH is total working hours invested in the development of the software system. And KLOC actually is not written here, I am sorry, but KLOC is a thousands of lines implemented in your software. FDFB, it's a function point development productivity. How to calculate this? We are gonna again divide DevH into NFB. So what's DevH? It's total working hours invested in the development of the software system. And third one is CRE, code reuse. What we are gonna do? We are gonna calculate the KLOC into KLOC. What's KLOC? Is a number of thousands of reused line of code, and KLOC is thousands of lines implemented in your software. And last one we have it is documentary reuse, which is docre. How we can do it? By dividing redoc into ndoc. So what is redoc? Redoc is a number of reuse page of documentation, and ndoc is a number of page of documentation.
So our first things in our presentation will be what are product matrices. So in very easy point, product matrices refer to the software system operation phases, and these operational regularly they take it in a very long time. It doesn't matter how much is it, but they sometimes recommend it if it is a 1 year. In this year they can collect or more data. So let's again say the explanation in more easy way. Product matrix refer to the software system operational phases, year of regular use of software system by customers, whether it's internal or external, who either purchase the software system or they are just making the contract with the developers. So as we say again, they collect the data to use it later to improve the program. And what are the type of customer service? Actually, we have a lots of type, but in our book they only mention two of them. They mention the help desk server and the corrective maintenance server. So what is the help desk server? And for shortcut they call it as a HD, and from now on I'm gonna say as a HD. So what is HD services? Let's go to the next one here. Yeah, as you can see here, we have the help desk service and corrective maintenance service. So what is the help desk service? Help desk service is software support by instructing customers regarding the method of application of software and solution of customer implementation problems. So as I told you, we are just collecting these problems from the customers and put them in cells. So what is the corrective maintenance server? Corrective maintenance server is correction of server failure identified by customer or detected by the customer services team. So as you can see here, we have slightly different here. So in the help desk server, we were collecting the data from the customers and put them in the cells, and after that doing whatever we want in these data, either fixing or changing. In the corrective maintenance server, we were taking it from the team support. So what is the difference between them? What's the difference between HD and corrective maintenance server? So HD matrices are based on all customer sales, while corrective maintenance matrices are based on the failure reports only. So as you can see here, the HD, it's taking all the sales no matter what. Sometimes the customer will say like, oh, there is slightly some slower in this part, slowly in this part. But for the corrective maintenance, they only take the failure report where the program or the product has been failed in this point. This one is more important for us. So the corrective maintenance service is work in this way. They only use the failure report ones. And we have some type of these software product matrices. So we have like the book only mentioned 4 of them, 2 for each one. We have HD quality matrices, we have a HD productivity and efficiency matrix. This is for the help desk. And for the corrective maintenance, we have corrective maintenance quality and quality matrices and corrective maintenance productivity and efficiency matrices. So let's speak firstly about HD quality matrices. For the HD quality matrices here, we have some category. This category, again, the book just mentioned 3 of them. So as you can see here, first of all, we have HD cells density matrices, and we have HD cells severity matrix and HD success matrix. And each one of them focusing in a specific point. So for the first one, cell density matrices, as you can see here, is measured by the number of cells, how many cells we have, how many how many problem we have, the customer send it to us. HD cell service matrices, it is what is the job of it is the survey of the HD issues raised. And for the HD success matrix is the level of success in responding the HD cells. So it's just showing us how much we are success for responding to these cells. So what is the HD cells density matrices? HD cells density matrix. For the HD cells density, there are 6 different type of matrices, some related to the number of the error and other to the weight of number, as for the volume or size. Measures for the software. Some uses number of line of code, while other apply function points. The source of data for these and the other matrices in the group are HD report. 3 HD cells density matrix for HD performance are presented as the following. I'm gonna show you right now in the table over here right now. As you can see here, we have the 3 of them. So how we can calculate the HD cells density? how much its weight, what's the value of it. So to calculate this, as you can see here, we are dividing NHYC into KLMC. So what is NHYC firstly? As you can see here in this key here, NHYC is the number of the HD cells during a year of service. As I told you in the first of my presentation, this process takes a year to do it because it's the best way to do it, because if you do it in every short time, that will be meaningless because you will not have enough data to apply it. But when you take a during of a time, which is like a year, you will have a good data set to work in it. And what is KLMC? It's a thousands of line of maintenance software code. This is the code that you call your program. And this is the one have problems. This is the one that the customer is complaining about. So you divide how many line you have to the how many report or not report, how many customer has give you an feedback about your program. And we have the WHDD, the weighted HD cells density. So how we calculate this? Again, we divide WHYC to the KLMC. What is WHYC? As you can see here, WHYC is weighted HD cells received during 1 year of service. Here is the weighted of the cells, but here was the number. In the first one, for the density, we were seeing the number, but right now we are seeing the weight. And again, KLMC, as you know from the first one, is a thousands of line maintenance software code. For the last one, WHDF, weighted HD cells per function point. So how we can calculate this? We are gonna divide WHYC into NMFB. So what is WHYC firstly? WHYC is weighted HD cells received during 1 year of service, again, into NMFB, which is the number of function points to be maintained. So right now we are gonna go to the second point in the HD, which is the severity of HD cells maintenance. So let's talk about it firstly. Severity of HD cells matrices. The matrices belong to this group of measures aimed to detecting one type of advisor solution. It might be increasing several HD cells. So the first component result may contribute to improvement in all or parts of the user interface, and it's usually user friendly, as well as the user manual and integrated help menu. And the other point is the average severity of HD cells, which is ASHC, which is you can see it over here, is referred to the failure detected during a period of 1 year. So when someone asks you later what's ASHC, you can tell them easily it's average severity of HD cells. And what's the meaning of that? ASHC refer to the failure detecting during a period of 1 year. How many failures in the system we had. So we can calculate this again. So how we can have a result from that? How we can show how much failure we had? So to calculate this, as you can see here, ASHC is the average severity of HD cells. To calculate this, we are gonna divide WHYC into NHYC. Again, WHYC, we just seen in the table before, is the weight of HD cells received during 1 year of service. And for NHYC, again, is the number of HD cells during a year of service. So we are actually dividing the weight of the weight of the failure by the number of them. In this way, we can have the average severity of HD cells. And we are gonna go right now to the last point, which is for the HD, which is the success of HD service. So success of HD service. The most common matrix for the issue of HD service is the capacity to solve problems raised by customer cells within the time determined in the service contract, and we call it in different word availability. The matrix for success of HD service compress the actual with a designed time to the provision of these services. For example, the availability of a help desk HD service for an inventory management software package is defined as a follow. The HD service under task to solve any HD cells within 1 hour. The probability that HD cell solution time execute 1 hour will not exceed 2%. The probability that HD cell solution time exceed for working hours will not be exceed 0.05. So by using this method, we are gonna actually save time, and we will have some expecting percentage of our output for the success action. Yeah, and how we can calculate this? It's HDSS, HD service success. So to calculate this, we are going to divide NHYOT into NHYC. NHYNOT actually is the number of really HD cells completed on time during 1 year of service. NHYC is the number of HD cells during a year of service. So what we are actually doing here, we are dividing the one that we finish it, the failure, and we solve it, into the number of the cells that we have during this year. How many of these issues we solve it? Into the number of all of them. So HD productivity and effectiveness matrices. Right now we are gonna speak about HD productivity and efficiency matrices. Productivity matrices relate to the total of reasons invited during a specific period, while effectiveness matrices relate to the resource invested in responding to HD customer cells. Yeah, so as you can see here, we are talking about HD productivity and efficiency matrices. So I'm gonna speak right now about the HD productivity matrices. So HD productivity matrices make use of the easy to apply KLMC measure of the maintenance software system size, or according to the function point evolution of the software system. Two HD productivity matrices are presented as the following. First one is HD efficiency matrices. Second one is the matrix is in this group referred to the resource invested in responding to the customer HD cells. And as you can see here, we can calculate them in this way. So for the efficiency and the productivity, first one we have the HD productivity. How we can calculate this? Again, we are gonna divide HDYH into KLMC. So what is HDYH? So it is total yearly working hours invested in self-servicing of the software system. What is the KLMC? It's the thousands of lines of maintaining software code. The second one we have it is the function point HD productivity. So we are going to calculate how much our function is productivity. So how to calculate this again? We are going to divide again HDYH into NMFB. So again, HDYH is the total yearly working hours invested in HD servicing of the software system, into NMFB, which is a number of function pointed to be maintained. And the last one we have it is the HD effectiveness. So it's gonna again divide the HDYH into NHYC. So we are again gonna divide the total years working hours invested in HD servicing of the software system into NHYS, which is the number of HD cells during a year of servicing. So as we talk right now about the HD, for sure we have some categories again for the corrective maintenance quality and matrices. So first of all, software correctively maintenance matrices deal with the several acceptance of the software quality of maintenance service. A distribution is needed between software system failures faced by the maintenance teams and failures of the maintenance service that refer to the cases of where the maintenance failure to provide repair that meets the standards or the contract. So we have 4 main points. First one of them is software system failure density matrix. So what is the software system failure density matrices? So what does it do? What's it deal with? So let's speak a little bit more about it. So it's actually deal with the extent of demand of corrective maintenance based on the record of failure identified during regular operation of software system. Second one we have is software system failure severity matrix. And actually what this method of work with or deal with, it's deal with the severity of software system failure assigned to be the corrective maintenance team. And the third one we have failure of maintenance service matrices. What's it deal with again? It's deal with the cases where maintenance server will enable to complete the failure correction on the time or that performance field. And the last one we have software system availability matrix. So what's it deal with? It's deal with the extent of distribution cost to the customer as realized by the period of time where the service of that software system are available on only partly available, when we don't have the whole, just we have a part of it. So how we can calculate these ones? So as you can see here for the software system failure density, so we are gonna do is divide NYF into KLMC. KLMC again is a thousands of implemented code, line of codes. So what's NYF? NYF is a number of software failure detected during a year maintaining of server. Put this in your mind that this year should be at service. You cannot just do it for the years that you were, for example, preparing or just managing. So it should be a maintenance during a year of maintenance server. It should be you were serving in these years. For the second one, weighted software system failure density, which is WFFFD. I have a problem here in the presentation. I am sorry. It's WSSFD. Sorry for that. WSSFD, weighted software system failure density. So what we are going to do here, we are going to divide WYF into KLMC. Again, KLMC is the thousands of line maintenance of software code. So what is WYF? WYF is weighted number of yearly software failure detected during 1 year of maintenance service. What about the last one, which is WSSFF, weighted software system failure per function points. So we are gonna divide WYF again into NMFP. WYF again is the number of software failure detected during a year of maintenance server into NMFP. NMFP is the number of function point designed for the maintenance server, maintenance software. And for the last one we are gonna calculate the average. So how we can calculate it? We can calculate the average severity of software system failure. We are gonna divide WYF into NYF. So what is WYF? WYF is the weighted number of yearly software failures detected during 1 year. So what is NYF? NYF is a number of software failure detected during a year maintenance server. This is for the system software system failure severity matrices. So what about failures of maintenance server matrices? So how we can calculate this? Maintenance reported repair failure matrices. What we are gonna do is divide REBYF, which is the number of reported software failure cells. Yeah, services failure, because we are working with a maintenance. Maintenance only work with a cells that have the failure report. It didn't take all the cells. Divided by NYF, number of software failure detected during a year of maintenance server. And for the last thing I'm gonna speak about it. After that, I'm gonna leave you with my friend, is the software system availability matrices. So the user matrices distribute between full availability, virtual availability, and total unavailability. So let's speak firstly about the full availability, where all software system function perform properly. We don't have any problem. So in this case, we have full availability. There is no problem. Virtual availability, where no virtual function fail, but non-virtual functions may fail. We are not sure. It might be 50-50. It might fail, it might not fail. We are not sure. Total unavailability, where all software system functions fail. We have total disaster. 100% fail in the system. And that's what you call it, total unavailability. That was my part. Thank you so much, and I will leave you with my friend.
In this presentation, I'm going to talk about Chapter 21, Software Quality Metrics. I will be talking specifically about the software of the implementation of software quality metrics, and I'm going to cover from page 427 to page 432. What are the subtopics of this chapter? Implementation of software quality metrics has 4 phases: defining the metrics, applying the metrics, analyzing the data and the result, and taking action according to the metrics analysis result. Firstly, let's talk about the implementation of software metrics. There are 4 requirements for applying the software quality metrics in an organization. Firstly, we have to define the software quality metrics. We want it to be relevant and adequate for the teams and the department and the problem we have. Then, we have to have a regular application by the managerial unit. We want to apply the software quality metrics. Then, we have the statistical analysis of the collected metrics data. We want to use statistics to analyze or compare the data we have gathered from the application of the software quality metrics. Then we take actions according to the response we get from the statistical analysis. These actions can lead to changes in the organization, methods of software development, and maintenance units, or any other body responsible for collecting metrics data. There can be changes in metrics and the metrics data collection itself. Also, the application of the data and the data analysis is going to be changed according to the result we get from the statistical analysis to plan corrective actions for all the relevant units. Let's talk about the defining a new software quality metrics. What are the steps for defining a new software quality metrics? Firstly, we have to define the attributes we measure. What are we gonna measure? What is the problem? Are we gonna measure the software quality? Are we gonna measure the development team and productivity, or something else? Because each one of these, they go into a category that they have their own metrics. Then we have to define the metrics. After defining the attribute, we have to find the metric that we're gonna use to tackle the problem and actually use it to measure a software quality of something like this. This is a confirmation for the adequacy in complying with the requirements. The third step, we have the determination of comparative target values. We want to compare the target values between years of performance with different teams or different departments. Then we have the determination of the metrics application process. This includes the reporting method, reporting process and frequency of reporting. Also, metrics data collection method. All of this will update and revise and change the new metrics we change the new metrics and will be constructed the analysis of the metrics data as well as the developments in the organization and its environment. What is the application of the software quality metrics? The application is the process of applying the metric or a set of metrics, which is also similar to the implementation of the new procedure or methodologies. Well, for this, we first have to assign the responsibility for reporting and metrics data collection. What team, what department, what kind of people are going to be assigned for reporting the result gonna be assigned for data collection sector, and so on. Then we have to have instruction of the team regarding to the new metrics. What are the new metrics? After we defined it, we defined the attribute, we defined the metric, we did the implementation, and what is the instructions? So we want to inform the team. Then we have the follow-up. The follow-up is the support for solving application problems, supplementary information when needed. Also, it includes the control of the metrics reporting for completeness and accuracy. So we want to follow up on the application of the whole process. We want to see how the solving the problem went on. We want to see how the team did it, and we want to see all the reports and to compare the accuracy and effectiveness. Then we update and change the metrics definitions together with reporting and data collection methods according to the past performance using comparative analysis. This is a graph or shape that shows the processes that we talked about until now. This is the process of defining software quality metrics. As you can see, we have the definitions, we have the 4 definitions requirements on the top. Firstly, we have the define and the attribute to be measured. We have to define the metrics to be measured attribute. We have the comparative target values, and we have the method of reporting and metrics data collection. After all of this, then we go to the manager and the application of the software quality metrics, which itself has its phases. And then we go for, after getting the results and data, we go for analysis of the metrics performance and effects of the environment changes. And all of this will lead into changes in metrics data collection, changes in the metrics itself, changes in the comparative target values, all the indicators. So we will redefine the software quality metrics. Also, the developments in the organization and its environment will have a straight impact on the analysis of the metrics performance and effects. After all of this is done, then we go for the metrics data collection and metrics data for manager control applications, which we'll talk about. Okay, so what is the analysis of the metrics data? After the application, we have the analysis of the metrics data. In the analysis, we do the comparative analysis, which is comparing a series of project metrics. We compare the metrics result against the predefined indicators, and we compare with the formal project or team performance at different periods of time. Also, we have comparison of the effectiveness with which the metrics themselves fulfill the respective aims. For example, we have data, we use the application of it, and we get the reports from the team, we get the data collection. So what are the steps? So we can compare the data and the result to series of the project metrics. We can compare it to periods, previous year or another company doing exact same thing, or even an example from the book, same metrics and attributes that China and USA did in different periods of time compared to each other, and the companies in a comparative analysis. And the goal is to, of course, find effectiveness and find any kind of flaw or the response to the analysis of these metrics. Okay, but everything is not done via comparative analysis. For the metrics data to be valuable, part of the software quality metrics process is statistical analysis and is required of the metrics result. So we do comparative analysis in the data of the quality metrics. For the results, we do statistical analysis. There are 2 types of statistical analysis. statistics in general. There is the descriptive statistics and analytical statistics. The descriptive statistics is the simple mean, median, mode, as well as use of graphical presentations such as histograms, cumulative distribution graphs, pie charts, and control charts. But analytical statistics goes a little bit further, which is regression tests, analysis of variance, or more basic tests such as t-test and chi-square test. Let's talk about descriptive statistics. What is the goal? The descriptive statistics illustrate the information to which they relate and enable us to quickly identify trends in the metrics values. Outlier trends identified by appearance of acute deviations from target values. Many indicate the need for corrective actions or alternatively to continue or expand application of the successful innovation. So what are the advantages of descriptive statistics? Firstly, use of descriptive statistics in quality assurance is easy and simple. We usually use simple formulas and simple graphs. And because of that, availability is very good. There are abundance of tools and packages in popular analytical and statistical softwares. What are the disadvantages? Because the descriptive statistics is not very thorough or advanced, so it's not intended to analyze the statistical significance of the results. And this is done by the analytical statistics. The goal of the analytical statistics is to determine whether the observed data metrics are meaningful. Whatever the direction, the observed trends must be assessed for their significance. So we want to see actually the result we got has any kind of significance. Advantages of the analytical statistics is we can analyze the statistical significance, whereas descriptive is not capable of such analysis. But for the disadvantages of the analytical statistics, exactly opposite to this descriptive, we have the application of the statistical analysis to the software system performance metrics is relatively difficult. So it needs more knowledge of the statistics and more literature to actually apply the descriptive analytical statistics to the result, to find the significance of the result, which is a crucial thing in actually measuring any kind of metrics performance. Need of more, and also because it's a more advanced and difficult kind of method statistics, we need more advanced softwares and tools and packages to use it, and many of them are not open source actually, or some. So let's talk about taking action. After we have all these results from the analysis of the data and the results of the applying and software quality metrics, what should be the results be? Well, the actions taken in response to metrics analysis can be classified as a direct or an indirect action. The direct action is initiated by the project or the team management. So it's done within the team and the project team itself. And its reorganization can be the changes in software development and maintenance method. It can be the revision of the metrics computed. So if any of these metrics show any significance in the results, the direct action would be the team manager, for example, finds that the productivity of the team is not really suitable, so we will hire new people or fire some people or change the responsibilities in its team. But there is also an indirect action. It's initiated by the Corrective Action Board, or CAB. Indirect actions are a result of analysis of metrics data accumulated from a variety of projects or development departments. So in this case, we have the more broader perspective. So in the indirect actions, we have the accumulated data from the variety of the projects. We can have the different departments, we can have different results, and we will have different actions to the problem here. And this is the end of I believe implementation of software metrics, and it is page 432. Thank you.
Hello, my name is Osama, and this is my part of the presentation. In this part, I'm going to be talking about limitation of software matrices and a summary about the whole chapter. And also, I'm going to be talking about the function point method. So let's start. So in limitation of software matrices, we have three factors limiting this software matrices, which is the budget constraints in allocating the necessary resources as like manpower and funds for development of quality matrices system and its regular applications. And we also have the human factor, especially positioning the employees in the right place and give them the right activities. And we also have the uncertainty regarding the data validity rooted in partial and based reporting. And software parameters, we have some software parameters matrices that exhibit severe weaknesses, like parameter used in the development and parameters used in products. In development, I give you example like KLOC or NDE. In the product, we have KLMC and NHYC. Now, limitation of software factors affecting development process and parameters. We have programming style, volume of documentation, comments included in the code. So we have the comments in the code, software complexity, and we also have a percentage of reused code. So the greater the volume of code that can be produced per day, as well as lower the number of the defect detect in reviews. And we have also professionalism and thoroughness of design review and software testing team. We also have reporting style of the review and testing results. So some teams produce concerns reports that present the findings in a small number of items, while others produce comprehensive reports showing findings for a large number of items. Now we're going to be talking about factors affecting the magnitude of a product. So we were talking about the development process here. Now we're talking about the product, so it's finished itself. And we also have quality install software and its documentation. So the quality of the install software, the lower the initial quality of the software, the greater the unactive software failures identified and subsequent magnitudes, example NYF. We also have programming style and volume of documentation, comments included in the code also. We have software complexity, and we also have percentage of reused code, and we also have the higher reused code is we also have the professionalism and thoroughness of design review software team affect the number of defects detected. We also have number of installations, size of the users, population, and level of application use. So, which people are using this code and what are they doing in it? And it's also affect the number of HD calls as well as the number of defect detected by user during regular use. Now we're gonna be talking about the chapter 21 in general. So in chapter 21, we're explaining the objective of software quality matrices, and we also be listing the requirements for a successful software quality matrix. We have general requirements and we have operative requirements. In general requirements, we were talking about relevant, valid, rebuilt, comprehensive, and multi-exclusive softwares. Operative requirements, as like it should be easy and simple, doesn't require independent data collection, and to be based in interference by strict patterns. We were talking about we were explaining how software quality matrices are categorized, and it's categorized like that. A two-level system of categorization is used. Process matrices and product matrices. So process matrices related to software development, product matrices related to the maintenance of the software when it's a finished product. Each first level category is broken down into one of three subcategories: software process quality matrices, software process timetable matrices, software process protective matrices. The software product matrices are classified into 4 HD and correlative main subcategories. It's HD quality matrices, HD productive and effectiveness matrices, software corrective maintenance quality matrices, software quality maintenance product and effective matrix. We also were talking about we were describing the process of defining a new software quality matrix. Definition of attributes to be measured, formulation of the matrix, and assignments of the adequacy, determination of comparative targeted values. We also talked about explaining the reason for limitation, characterization, some software quality matrices, software development matrices that are based on measures such as KLOC, and we also were talking about product maintenance like KLMC. And now let's talk about the function point method. So basically what function point method does is used to size a product or a software, and it's done like this. It's done in 3 stages. First stage is calculate and create function point. Second stage is calculating the relevant complexity adjustment factor. Third phase is computing the number of functions point. So how we do these stages is by we take, for the first stage is calculating crude function point, is we take the number of users, we take the inputs, outputs, user online, number of logical files, number of external interface, computer, readable, everything. Then what we do is we calculate the relevant complex adjustment factor, which is we call it RCAF. The relevant complexity adjustment factor is summarize the complexity characteristic of the software system by assigning grades from 0 to 5 to 14 subjects that substantially affect the required development efforts. And stage 3, we take what we calculate it, and we calculate the function point by calculating the function point value for there is stage 1 and stage 2 by applying the following formula. So CFP, which is in stage 1, we multiply by 0.65 plus 0.01. We multiply it by the number of complexity adjustment, and that's it. Thank you for listening. Have a good day.